right. Welcome back. Hello. How's it going? Nice to see you again. I am Agent Ultra, James, whatever you want to call me. All good. And we are here today to program some stuff in Haskell. I have some C code up here. I should probably get rid of that. Because, gross. C code. We're building a project called LambdaTrek on the stream. And in LambdaTrek, if you haven't seen it before and you're just tuning in for the first time, welcome. Our project looks like this. It's basically like a roguelike type of game where it's like all tile-based and turn-based. And we're using the wonderful, fantastic Haskell library called Brick to provide our user interface for the game. And you basically give little commands to your ship. I don't know what to call it yet. Just call it ship. And you give the commands to raise the shields, lower the shields, fire phasers, that sort of stuff. Like you kind of like do in a Galaxy-class starship of some kind. And the goal of the game is to take out all the enemy ships that have sort of invaded your quadrant of space by visiting all these different sectors, and do that before you run out of turns, or don't run out of energy or hull or things like that. So the S is our ship. We've got some space stations. We've got enemy ships there. We've got stars that represent stars. And we have some commands like moving around. Like that. Oh, that would move us directly into the enemy ship. So we'll move to A2. So we're next to the enemy ship. We can fire our phasers. And we could give it like an energy amount. And that destroys the ship. We took a hit from that, but there you go. And then we can recharge by docking at the station. Recharge our stuff. That kind of thing. And of course we have like this nice little combat log, this game log that kind of shows you what's happening and stuff in the game. And that's where we are, the game. Last week we were starting to get to implementing shields command. So let's continue on with that and get it going. Okay, so I'm gonna open up my code. Let's see, do we have any branches? No. Source, LambdaTrek. We're gonna go into simulation. So we handle most of like the game state changing things that update the simulation, docking, collisions, things like that. And then various subsystems of the simulation we've broken down into little modules like combat, things like that. Shields, enemy fighting, enemies, controlling enemy states, handle shields, there we go. Let's see, shields are up. Yeah. Shields down. Okay, so we've implemented that. Then I think the next step, we should probably show that in the UI, and then update our combat stuff so that the enemy firing at us with their phasers interact with our shields, right, if they're up. Okay, so we go in the UI. This is where all our UI code is. Our info panel is our widget for displaying ship data, ship information. Oh, look at that, we have ship state. So maybe I was just ignoring that part. So I don't see it here. Oh, maybe we just need to rebuild. Let's get my build, let's fire up the builder. Oh, we'll use the test runner as our builder. Fast, file launch. Because it also recompiles the project as you go. Oh, of course, I'm in the wrong directory. And then we go to LambdaTrek. Try that command again. Bang. Okay, how are the levels tonight, by the way, chat? Cool. So if you are tuning in, feel free to just drop me a question anytime you feel like you see something needs explaining. Happy to answer questions. Okay, let's see. The shields. Yeah, okay, the shields are there. So we do have the shields command. Shields up. Raising the shields. Cool. Shields down. There we go. Cool. Let's see. LambdaTrek, I think. Yeah. I'm not going to go for a direct clone of LambdaTrek, of course. I think we're going to take some liberties here. To do our own thing a little bit. But it's good to take a little inspiration from it. So it does cost some energy in LambdaTrek to raise the shields. Nothing to lower them. So I think that's probably a good thing. Each time you raise or lower your shields, the enemy ships will have another chance to attack. Since shields do not raise and lower instantaneously, the hits you receive will be intermediate between what they would be if the shields were completely up or completely down. I don't know if we will implement that. We might just implement it like straight up, straight down. Because that could just make the code a little bit more complicated than it needs to be, the way we have it set up. But you do what's fun in game design and game development, of course. It's your game, you know. Do what you like. What makes you feel good. What makes the game feel good. But we'll do that first. We'll just make it cost a little bit of energy. So we go back over to the simulation. Bang. Yeah. So if we go, this is the prior state and then the new state. I think I might rename that. Just so that it's more clear in the code. I'm not gonna be able to multi-edit. That's okay. Don't need to. It's just one spot. Okay, so you get the prior shield state and the new shield state. So if the prior shield state was shields down and then we go shields up, we raise the shields. That's where we set shields up. We should also decrement the energy amount. I think we get a minus equals 50. What we need to put a do around that? Sweet. Okay, it costs nothing to lower the shields. Just shields down. Oh. Okay. Like that. Okay, so then how do we want to like model shields in our system? All right. So in LambdaTrek, the shield, it says the shields protect you, they gradually weaken. So there's like a strength value to the shields. So if they're at 75%, that means the next time the enemy ship hits you, your shields will deflect 75% of the damage and let 25% through to your hull. So that should be pretty easy to model as like a value between 0 and 100. And I guess if the shields go down to 0, then they will let everything through and go down into the down state. Let's see. So it costs 50 to raise your shield. So no. They do gradually weaken. Okay. So each time you raise or lower your shield, they have a chance to attack, blah, blah, blah. You may not fire your phasers through the shields. However, you may use the high-speed shield control to lower your shield's fire phasers and raise the shields again before the Klingons can react. So, enemy ships. Since the rapid lowering and raising of the shields requires more energy than normal speed operation, it costs you 200 units of energy to activate this. is automatically activated when you fire phasers while the shields are up. And you can transfer energy between the ship's energy and the shields using a different command. The amount of energy transfers the number of units of energy we should take from the ship's energy and put into the shields. If you negative number, you can drain the shields. Transferring energy costs a turn. Okay, so we'll implement transfer later. For now, let's do shield strength. And then update the combat stuff so we can see that the shields are absorbing the right amount of damage from the enemy attack. And then we can implement the transfer stuff to make it a little bit more interactive and interesting. Okay, so in our simulation, we simulate the ship in the ship module. Let's go there. Bang. And then we got that. So shield state. Shield strength. We could just make this float value, or like a double, between 0 and 1 to represent the percent amount. I might make the formula a little bit easier in calculating damage, perhaps, as long as we have an interface for updating it that isn't just like a function for updating it that isn't just setting it, so we don't make any mistakes changing it. Otherwise, we're going to need like a special, we should put a special type on there just so that people know, or I know at least later on, what it should be. Let's try that. Let's go double. Add a little code comment. Between 0 and 1, representing a percentage of damage reduction. And I suppose, well, we'll get to that when we do transferring. Let's just do that. Then we need to update the initial state setup for our ship, our default game state. And we'll make it 75%. I think a bunch of tests are probably going to break. Okay, so I'm just going to do hopefully a quick minor with 0.75 because we don't really have anything else touches that yet. Super. And while I'm here and thinking about it, I'm going to see, what is this? Non-exhaustive pattern matches. Okay, I'm going to ignore that. I think you can set that on a per file basis. I don't remember the syntax for it off the top of my head. Options GHC or something like that. I think there was something in the search results. Options. Okay. Dash W, no, whatever. Okay. Okay. Yeah, that's a little cleaner build, good. In test code, I don't really care, because like I'm expecting these sorts of things. I wouldn't use that in production code, like in our main code, of course. But this is a good warning to have, but when you know that this is going to be that way and you want to like just like fine with shooting yourself in the foot about it, then don't worry about it. Disable it in test code. Okay. So that's that. Let us update now. Let's create commit for that. Add ship shield strength to the ship. Okay, and let's go update the enemy attack and make it reduce it by the percentage of the ship amount there. I think we have that in here. We might want to do a little refactoring, move some of this stuff into combat. Just gonna leave it here for now, though. So that's the updating enemy state. Handle enemies. So this is actually like handling the enemy actions. And handle enemy fighting is where we handle the fighting. So when the ship is in range, then we are going to do some stuff here. Okay, so first we're going to... what do we have here? We have a hard-coded value for the damage amount. We're just subtracting one from the hull. Okay. So, to make this a little bit more interesting, enemies will need to throw something a little bit more at us. I think maybe we could go with like a base value plus like a small random amount. And that would be cool. So let's add a base damage amount to the enemies. They are in the simulation as well. Are they? Yeah. Yeah, simulation enemy thing. Not in AI, but in here. There you go. I should figure out what I have that AI module for. Let's go. Okay. So we got enemy state, and we need enemy base damage amount. Okay. That's going to break a bunch of stuff in the base sector. Okay. In our default sector. Okay, let's make the base damage like, I don't know, 10. And maybe the test code might need updating, perhaps. We might need to do a little bit of refactoring on the combat module too. Simulation, combat. To better use lenses so that we don't have these pattern matching problem. So I run into this a fair bit where I start off using pattern matching. And I'm like, yay, cool, pattern matching out records. And then it gets kind of annoying, so you use record wildcards, and that has certain restrictions on it, and that gets annoying. And so I'm really enjoying using lenses these days. So that is on line 112 here. Generate damage dialogue. Interesting. It's not using... We're using record wildcards here, which should be fine. Weird. Sorry, I'm not sure where that's coming from, what that's all about. I'm gonna get rid of this debug code here. Oh, that should be pipe. Okay. Okay. I think maybe this is no bound variables in the record wildcard. We're not using any of the variables in the record wildcard match here, so we don't really need it. I think we're really just using that for debugging. I don't know why it's still saying that. That's more what I was expecting. So maybe GHCI and my Emacs here just hasn't caught up yet. But the tests I was expecting to be broken, so let's go fix those. Example enemy. Ten. I think I could do a similar trick that I did before. Except for that. Skadoosh. There's a couple of ones that are like a little bit mistakes. 261, 272. I think I nailed that one already. No, good. And one more, two more. Okay, that was a bad idea. That was a bad idea. The other day. Let's get those cleaned up now. Clean up. Those ones are all fine. Should be 10. Should be 10. Yeah, okay. Let's see what else we got here. Sorry, GHC, we missed one, buddy. Fix it. Thanks, pal. Okay, and then a bunch where we construct the record by name. And that's super fun too. Skadoosh. Skadoosh. Couple here. Skadoosh. Badoosh. Zoom bazoom. Okay. Enemy damage amount, enemy damage amount. In here, in here, in here. There. Okay. We're back to green. That's good. Let's create a commit. Add a base damage amount to enemy. Okay, now got a base damage amount. Now we need to add that little bit of like factor. That's the official technical name for it in game design. All right. Okay, that can be. Let's see. Go into simulation here. So we're going to calculate our randomish amount using our random generator. Right, we have one of those, don't we? Yeah, we have a random gen here. That's good. What do we use random gen? Let's capitalize that. Random gen in source. We do use it in combat. Random phaser factor. Let's see. Okay, so instead of a random float, let's get a random integer in range. Let's create that function. So we're going to need that. It probably looks something like that. No, sorry, int. I'll take a couple of input parameters, our low and our high. Return something kind of random between that. Just leave it undefined for a moment. So we're going to go into simulation again. So we go here, we'll get our random factor. I don't know why I put it there, but I did. damage, extra damage. We'll call it like this, random range, say between 0 and 5. All right, so then our total damage will be the enemy base damage plus our extra damage. And maybe we should have like a function like we have for the enemy ships where we could say like damage ship with that amount. So enemy we'll do enemy base damage amount plus extra damage. Okay, I don't have damage shift and scope because I haven't defined it yet. I meant, okay, I guess I have to have that scoped. Okay, we want something like that. And then combat dialogue is gonna have to change a little bit because like the ships are gonna, the shields if they're up are gonna absorb a little bit. Ooh. Yeah, the damage ship function can take care of that. We should probably get some kind of result from the damage to generate this say dialogue thing. And then we don't need to set this directly. I think this looks a pretty nice code. This is the kind of code I want to write, so I think it looks pretty nice. So let's make it all compile and work. First, we need to define damage ship, apparently. So I'm gonna go put that in the ship module, I think. So this is going to take the amount that we want to apply, the amount of damage we want to apply to the ship, and it's going to do all the calculations with the shields and everything. And apply the damage and return some kind of damage results. So it's going to be in the state mode, game state, and damage results. You'll have to define what that means in a second. And we'll just ignore them out for the moment. Create a type called damage results. And what kind of damage results do we have, really? We have like a direct hit result. We have like a shields took some amount, maybe a bit of hull damage. And then we have like the shields absorbed everything, if that's even possible. Can we miss in our game? Okay, so yeah, our damage result should basically tell us, like, I guess, how much the shields were weakened by things like that, maybe? Maybe we don't even need to return that. Well, no, I think we kind of do. Yeah, so let's do that. A damage result. All right, we're gonna have like shield, weaken, damage result, shield, weaken amount, something like that. That might be a double. Whole damage amount. Some integer amount. Something like that. Damage results. Direct hit. Is direct hit? Something like this. We'll know more once we start writing it out a little more. I'm just going to leave that the way it is for there. We have a couple of imports to get. LambdaTrek. State. Oh no, we have an import cycle. Oh, that's annoying. Well, how else could we do this? We could do it like this, where you pass in the ship and we give you the new next state of the ship to apply, and then it's your job as the caller to add that ship back into the game state. Yuck. To break this cycle up. So an import cycle is like when a module, like, they reference each other. They form, like, in the dependency graph, a circle. So who is supposed to import who first? The chicken or the egg kind of problem, right? So to break that up, usually you have to, like, introduce, like, a new module that, like, the siblings can inherit the common elements from. And that parent mod now becomes a parent module, and then the parent module can just break up the cycle and not import any of its children. Or maybe it's the other way around. But either way, you just have to break up that cycle, and usually that means introducing a new module or moving things around. It's because state is importing ship, I think. Certainly is. Okay, so basically, I think the easiest way is just not to put this in here. Actually, let's get all of that. Let's go back to simulation module. I'm gonna put it down here. Why not? Okay, now what do we got here? LambdaTrek.s. Oh, what did I do? Get rid of that, get rid of that. Okay, and now, Chikatero, we have damage result here. Yeah, actual type damage result, okay. Super. Okay. We have a generate damage dialogue. Do we have that already? I guess, though? Oh, we do. Oops. Okay, we have generate damage dialogue. We'll have a... to name it something else. Quick damage. And we'll put that here as well. Ship damage. Dialogue. Oh. The estate to... that'll be a damage result. Game state unit. Ignoring the argument, just being undefined for now, just to check, make sure all the types line up. Okay. The tests are all broken right now because we're hitting the undefined state here. Because we're changing the damage function that all the tests were using. So that's to be expected. Okay. So that means we're good here for this part. Let's start filling some of these in now. Let's do the random range function. So we get the generator out. And then random R, something like this. Some expression in there. Get state, random gen. We're going to assign it back to the new state, new generator state. And then we return pure something. Okay. Haskell, the random package, system.random. So what we use there for this. So we have a general range no longer used. Okay, is there a different one now? key. Oh, random R. Okay, it takes low, high, pseudo random energy. Okay, so very, very similar to what we have already with random phaser factor. So we're going to use integers. X. And return X. Okay, so that's good there. Random range. Now we need damage ship by a certain amount. Let's go amount here. Okay, this is the meat of it. So damage ship. We're going to reduce the amount of damage by the shield factor if the shields are raised. Alright, so we're going to need the ship. And we're going to need a pattern match on the ship's shield state. And shields up something. Shields down something. Something like that. Excellent. Okay, so in the shields down case, pretty straightforward. It's going all the damage is going to go straight to the hull. All right, so we're going to subtract the amount from the hull. So we're going to zoom in on that ship. We're going to set the ship.hull to minus equal the amount. All right, and then we got to return a damage result. Yeah, there we go. And we're going to do pure damage results. That's going to be 0. Shields are down. The hull damage amount is the full amount. And is direct hit will be true. Okay. In the shields up case, the hull damage amount is going to be reduced by the shield's strength. So it's going to be the shield strength is a double between 0 and 1, so we can just multiply the amount by that. So we amount that should give us 75% of that. And then we subtract that from the amount, right? So we want to get 75% of the incoming damage, which, yeah, we multiply by the shield strength. And then subtract that from the damage amount so that we get the remainder, the remaining 25% applied to the hull. We have to weaken the shields by a certain amount, which isn't really specified there, but I think we can come up with a reasonable formula. Okay, so the hull damage amount is going to be the amount times the ship shield strength. Right, that's going to be, say, 75% of our input amount here. And we're going to subtract that from the input amount. Okay. And then we're going to zoom in on the ship. And we're going to reduce the hull damage amount. Okay, and then we have to return a damage result. Shield weaken amount. We have to think about what we're going to do for that. I'm going to put it as 0 for now. We can think about it in the next bit. Let's just get the shield damage, the hull damage going. So we hull damage, we're going to use hull damage amount here. And damage result is direct hit, is going to be false. Sorry, it's hull damage amount. There we go. Okay, so Haskell's just complaining here because we can't match types around the multiplication operator here. So just wants to make sure we can just do a little int change there, I think. Even more parentheses around that to make it super clear. Is that the problem? Oh, yeah. Okay. There's just some more dependencies happening here. So it's, because we're subtracting from amount, this is also an int. Okay, that resolves that, and then we have to go to an integral. We have to use like floor or ceiling. It could be harsh and go ceiling. I mean, it's not going to matter a whole lot. Ceiling. Since we use it twice, I'm actually going to make it part of that formula. Going a little over to the right, but that's okay. It's not too bad. Okay. That's good. And what's this warning here? There we go. Handle engine move. Ooh. I think we should fix this code here, but we'll do that in a different pass. Strength. Ah, shield strength. Jeez, fingers. Pay attention. There we go. Sweet. Okay. Just a couple more, some undefineds to fix. So that's good enough to get through that. Let's get our other undefined. So generating the ship damage dialog now. Let's get our damage results out. Okie dokie. So once we get our damage result, we have how much the shields were weakened, how much damage we have to the hull, and whether it's a direct hit or not. I think we might not actually need the direct hit boolean because I guess that depends if the shields were up or not. So we might still need that. Although this ship, you can't weaken the shields if they're not up. So we might actually not need that boolean. Yeah, this is kind of what I was thinking, is like, now that I look at it, I'm like, And so if the damage results shield weaken amount is equal to 0, then we know it's a direct hit. So we just use our say dialog, combat, we took a direct hit, Captain. Otherwise, we could say that shields holding, we took some damage. Something like that. Might be good enough for now. Like we can update this and use some of the values there that we're kind of ignoring. Maybe. Okay, just wanted to see some green there. That's good. Let's test it out. We haven't tested it out in a while. Bam. Bam. So let's put our shields up first. Raise those shields. Okay, raising shields. Energy went right down. Boom. Let's move closer to the enemy ship. For some reason this says we took a direct hit. Oh, because we didn't implement weakening shields. Because our hull is only 6, okay. Makes sense to a degree. Okay, so that's looking okay, but I want to implement either a shield weakening or, yeah, so we can get rid of this boolean. Okay, so we should weaken the shields. We need some kind of like scaling factor formula for this based off how much damage the input energy was, I guess. It's probably what we want. And turn it into a number between like 0 and 1. And then we can subtract that from the thing. Right, so if we take the current shield strength, now if we took the current shield strength and how much damage that would have been, so just this part of the formula. Then, yeah, we can multiply that by itself to get a percentage from the whole, and maybe reduce it by that amount. That might work, maybe. Let's try and see what happens here. So. Shields reduction amount. Or damage. Reduced damage. Shield reduced damage. Something like that. Shield reduced damage amount. It's going to be this part of the formula here. And that's going to be shield reduced damage amount. Right, so in our example that we've been going through, right, like this is going to be 75% of the amount, the total amount. And then hull damage amount is going to be the amount minus what was damaged. So that's the remaining 25%. We could just make it a constant factor. It reduces your shields a little bit, like 2%, something like that. So let's just do it that way, because it'll be simpler. And also because I just don't want to sit here and think on stream for like really hard for 20 minutes. Okay, so if we do reduce the ship hull, we can reduce the ship shield strength by 0.02. A little do on it. Put a little H on there. Strength. There we go. I can spell it properly. I am so smart. SMRT. Sweet. Okay. Okay. So that is now implemented. So then we should put that in our damage results. That's just going to be 0.02. We might not even need that. Okay, well, let's just test it out, see how it feels. Raise those shields, baby. Up. Okay, let's go into battle. 8-2. Okay, shields holding. We took some damage. We see that. We took a little bit. All went down to 7. Energy took a little bit of, reduced there for movement. That's good. With our remaining phasers. No, I guess LambdaTrek says we shouldn't be able to shoot through our shields, but we're just going to do that. Alright, we destroyed the... ooh. There, now we destroyed them. Aha. But then we can dock. Boom. And we're back up on energy. Our hull's back up. Our remaining turns went down quite a bit. And there you go. Starting to feel a little bit more game-like. Combat's getting a little bit more interesting. Okay. So let's, now that that's kind of working, let's kind of compress down and take out what we actually don't need here. And then I think we should implement the shields check. So when the enemy, or when we go to fire, we shouldn't be able to fire through the shields. We can implement all of that stuff because it makes it kind of interesting, I think. Sounds neat. Let's do that part. Let's see. We don't need the weaken amount because that's going to be a fixed amount. So what I think is we should keep the direct hit bool and test that. And done. Done. Let's realign that quickly. Here we go. And is direct hit. And let's use the amount, the damage amount, at least. Yeah. Say dialogue. Let's do this. Then we're gonna go, we lost. Show damage results, all damage amount. And we gotta pack that in text. I'm going to need to import. Oh, I have it imported already. It just does text. So in this else branch, actually, we could update this text branch to say, like, whether the shields are actually holding. Because if they go down to 0, they probably should say something like, they should change state down to shields down. And then we should be like, shields are no longer holding. And like some, actually, maybe we don't want to show the point of value here in the text field. I feel like the dialogue I want to keep as like ludonarratively like makes sense as much as possible, like it's in world. And so if you're watching the show, whatever show that might happen to be, LambdaTrek, you wouldn't necessarily hear someone at the helm or the station say like, we took 10 points of damage. They would like have a more extensive damage report, but we're not simulating all the innards of the ship here. We're just kind of trying to simplify things a little bit. So just like we did with the enemy damage, I think we want to maybe like have it kind of say some, a little, or a lot. And then you can look at the info panel if you want to see the point values. I don't know. These are the kind of choices I think you need playtesters to like tell you if it's a good idea or not. So let me know what you think, at least, chat. You can be my pseudo playtesters for now, unless you actually want to go and build the project and play with it a little bit yourself. Then tell me what you think. Although it's still pretty simple right now. So, that being said, let's add a little let's add a case statement on, we can get the ship here, ship state. We could do a case statement on the ship state, shield state. Shield state of shields up. Or shields down. We lost shields, Captain. Taking damage. Pull that a little bit over the left. See if we can get that. Yeah, nice to read. There we go. Even better. Well, apparently that one won't work. There we go. That's better. Yeah, yeah, okay. Move this over too. Hold that up. No. No. It's fine for the else block, but not the then block. Like it indented like that. Okay. So if it's a direct hit, then we do that. If the shield state is down, we lost shields, taking damage. Okay, cool. I think some damage is okay here. Well, I think that's the next thing we should do is like damage amount. Do it like this. Int to text. Damage amount. If amount is less than 10, a little. If, oh, sorry, syntax here. the amount is greater than 10, and the amount is greater than or equal 10, and say less than or equal 10. The amount is greater than 10, and the amount is less than or equal to, I don't know what the scaling of the game is right now. I'm just gonna play it off the top of my head, say 40. Some. Otherwise, it's gonna be something higher than that, and there's gonna be a log. Let's import that type directly. Okay. It's good, and then we can replace that in here. So here, put that off there, and there. Little space. Here we can do damage amount. And we can use the damage result, all damage amount. All right. Okay. And then just say less than equal. Okay. I think the shields down case is actually pretty nice. So it's a string there with all shields captain taking damage. We took a direct hit. And then we can do the same thing here. Use damage amount instead of showing it here. And then space damage. Okay, I think that should look good. Test it out. Shields up. Move into combat. We took some damage. Okay. Shields holding. Okay, fire phasers. Use 30 of energy. Destroyed it. Good. Let's dock. There we go. Awesome. Alright, so that's cool. I feel like I want to see the current shield strength. Speaking of the shield strength, and then maybe we can work on... We got a bit of time. Yeah, I want to see that in the UI, I think. Because I need to know as a player, like, if I need to divert some energy, or forthcoming transfer energy command or whatever, to the shields, or if I want to take energy from the shields. So let's go to the UI. It's pretty easy to add to our little info panel here. So we'll add it after the shield state. I'll call it shield strength. And we got to, what do we got to do? We got to unpack it from text. And we need to represent it as a percentage, not as a 0.75. It would be like 75%, 50%, that kind of thing. Yeah. So that's going to be a sun function on game states. Game state ship dot shield strength. call it display shield strength. Yeah, we'll just write that here. Display shield strength. That'll be undefined for now. Game state to game state. That's what I was thinking. Double the string. Double to string. Double to string. There we go. Okay, so then in order to convert that to... we multiply it by... well, we are expecting from 0 to 1. And we want to turn to like a decimal representation of like a number, a digit, like a whole number, 0 to 100. So we multiply it by 100, call floor on it, and then we can convert that into a string. I think that might be good enough. Hopefully not, it won't be terribly inaccurate. D times 100. And then we will text pack. Well, it needs to be a string, so we won't even use the text. We'll just use show amount plus %. Probably show here. Oh, it just doesn't know. Okay, yeah, I'm gonna show as an integer. And we move the brackets here to make that go away. Is that how it goes? Okay, that seems happy. And what's on here? I need to enable type applications. That's what I thought. Okay, that looks like a good. Did we build properly? No. Yeah. Okay, that's fine. It compiles. Let's just try it out now. Right, shield strength is at 75%. Awesome. Shields up. They are up. Smooth. Shield strength is down to 73%. So we reduced by 2. That's good. Our hull is down 6 to 6 this time. And we must have rolled a little higher that time. Phasers. We don't have that much. And then the enemy gets a turn. Because we messed up. 30, there we go. Dock, boom. Cool. Alright, we're still like, we're getting close to the end of the stream, but I think we still have enough time perhaps to start implementing the transfer energy commands. We start transferring more energy to the shields. Cool. Let's commit what we have so far here. Reduce enemy damage by shield strength. Booyah. Okay, now let's add a new command. So we've done this a few times now, and now we get to remind ourselves how to do it again. So every time we want to add a new command, we go to our command module first. We add the type. So transfer. We need an integer amount. It's the command. So we're based off of our good old LambdaTrek command. Transfer. They implemented, looks like a shield transfer. I don't know if I want to complicate our parser that much. We could just implement it as a separate command. Transfer X amount of energy to the shields to raise shield strength. Put that there. Okay, so turn cost for transfer would be 1. Pretty fast. Okay, and then we need, the next step is to implement the parser. Center command / parse. There we go. Add it here. Parse transfer. Gonna be a read p of either command parse error or command. Okay, so what do we need to do? We first need to match the string and transfer. And then skip spaces. An integer amount. It's going to be a digit. And then EOF. And then we return pure. Right. Transfer amount. Then we add it to our parse command parser. It's kind of grand poobah of all the commands. It tries each and every one. There we go. All right, and then we can go to simulation. Handle command. This should be... This shouldn't be compiling. Yeah, there we go. There's our pattern match error. So we also need here transfer. Put amount here, and we'll go handle transfer. So we have to go implement, handle amount, handle docking, handle shields, handle amount. That's going to be a state, game state, unit. No, it's a command, so it has to return a command results. Let's just see that this is all wired up correctly and parsing properly. So we'll just do like, say dialogue. Let's add a new helm. Let's add a new character. Let's add engineering. Transferring text pack. Go amount to shields. Hi. So we don't have engineering defined. They are in. Where are they? Simulation? Or is it in the dialogue system? I can't remember. Where did I put it? Simulation, render, list, command. No. Dialogue. It must be in dialogue. Yeah, okay. Engineering. There we go. That's what I was looking for. A little bit of a brain fart. We're back on track. It's all good. What's that warning there? Yeah, handle transfer is not in scope still. Call to handle amount. Silly me. Oh, wait, we gotta return a command result. Performed. And that should compile. Cool, let's test it out. Bang, bang, bang. Okay, transfer 20. Ooh, we're missing something in UI. Oh, it's a runtime one, yeah. There we go. From crewmate. And so not all. This is one of those cases where if it compiles, it works. Doesn't always work, as if you ignore warnings like the exhaustive pattern matches, because they're not getting reported for some reason on this file by your builder, which is kind of odd. Might be a bug there. Yeah, you're not going to get 6. Or maybe my stack configuration for this build target isn't listening to warnings. Either way, engineering, we got to give it a color. And LambdaTrek. We're going to have to I'm not gonna get too TNG here. I'm gonna have to go like maybe blue. I'll try blue. And engineering. Like that. Okay. Hopefully that's all taken care of now. Okay, build done. Transfer 20. I accidentally put a space underneath at the end there, which makes me think we should probably add a skip spaces to our parser there. Okay. That almost worked okay. What am I thinking here? Oh yeah, the parser. That's one thing. Let's just add an extra skip spaces here. Go ahead and add one here too. I think that could be a common like whoopsie, and it doesn't really hurt to add that. Let's see, up, down. Let's see, suggestion here. Oh, just some common pattern here. I'll ignore that for a moment. And just make sure that that feels nice. Yeah, okay, that's better. Yeah, I like having that just be a little bit more permissive there. That's good. Another way we could probably do it is just to like strip the text before passing it into the parser, maybe. So then we don't have to have these extra skip spaces everywhere. Might do that, actually. Just like we uppercase everything. Run command parser doesn't uppercase the input string. Maybe means the UI does. No. Maybe. Simulation. UI. Parse. Where's the command parser used here? Run command parser, where are you used? An app. Okay, yeah, right there. Text, I think data.txt has like some kind of string strip kind of thing. yeah, remove leading and trailing white space from the string. Like that. Just add it to the pipe here. I'm gonna name that. I feel like I want to name that too. Anyways, I'll leave that for now. I'm just going to do that like that. Just make sure our parser still works. Okay. Yeah, there we go. Cool. If I space move, yeah, it still works. Okay, that's nice. And transfer 20 space to database still works. Okay. Cool. All right, I kind of mixed a little bit of parser handling stuff in that as well. Some improvements there, but that's okay. Let's commit that. Add the transfer command. Transfers energy to shield strength. Okay. We're going to have to finish implementing that feature next week. We are just out of time on the stream, unfortunately. Our time here has come to an end. Thanks again for hanging out with me tonight. It's been a little quiet tonight, chat, but that's okay. Maybe next week. And if you liked what you enjoyed tonight, and you liked what you saw, you liked what you enjoyed, you liked what you saw, I'm just pushing the code up now. All of that is on GitHub. I'm Agent Ultra. This is my GitHub here. It's on at LambdaTrek. So everything you saw here for this project and we've done so far is available here. You can, do what you like with that. I'm also on the socials here on Mastodon on the types.pl server. I'm Agent Ultra there as well, and here on Twitch. So if you want to be notified by future streams, because this is your first time tuning in, or you just haven't hit that button yet, you can subscribe here to the stream. You'll get notifications when I go online and all those sorts of things, because sometimes I do occasionally stream other things, or like surprise streams and stuff, whatever. So you get those. And if you're following on YouTube, on my YouTube channel, where I archive my streams there, because you're in a different time zone or what have you, you know what to do there as well. Right? Cool. So following the link above, you'll get to our Discord server. All right. There's a lot of cool people there that stream in other programming languages, including Haskell, there as well. And we have a channel for the stream here. So if there's a question you're dying to ask, or you want to show off your project or just chat, whatever, show up. It'd be great to see you and talk to you. Thanks again. May your monads always be free and your types always check. I'll see you hopefully next week around 10 after 8 or so in the Eastern Standard Time Zone. Take care. Bye-bye.